Hello, everyone. Thank you for joining us. I'm Jack Rocca, and for the past year, I've been fortunate enough to work alongside Layla and Matt on the Construction Error Detection Senior Project team. Working with us on this project, as you can see in the top corner, was John McNulty and Kevin Albaugh from MBH Architecture, a worldwide architecture firm based in the San Francisco Bay Area. Before we go any further, we would like to thank them for their time and effort, as well as IAB member Sam Aborn, who helped us along the way. Diving into our project, as we worked with MBH, we began looking into their recently completed project on 300 Grant Street in San Francisco. This building is in a popular historical district of the city, and as you can see, it contains several complex features. While visually appealing, complex designs are often harder for contractors to build, and that, along with the civil grade differential, introduced several challenges for the contractor. Most significant to our project, however, is the fact that over 300 RFIs were filed during the construction phase. RFIs are requests for information, and in a moment here, Layla will begin to further explain those. Since MBH viewed 300 to be a high number of RFIs, we framed our problem statement around this. In a simplified form, our problem statement was to decrease the frequency, time, and cost associated with RFIs.
So in order to figure out where specifically these issues arise with RFIs, we conducted an interview with WebCore Assistant Project Manager Galen Doherty. And through this experience, our team learned that subcontractors are actually the ones performing most of the labor on the job site, and that there are often huge communication errors due to RFIs. So following this interview, we completed a literature review centered around RFIs, and we learned that throughout the physical construction phase, it's really common for projects to require design changes or clarifications. So these are most often requested by subcontractors in the form of an RFI and includes what needs to be clarified by adding many different attachments to the RFI. So on the left here, you can see the American Institute of Architects, or AIA, document that is the widely agreed upon standard RFI form that in theory should be used across the industry. So even though this is considered a standard format, most companies actually use their own version of it so that they can put their logo on it. However, generally these include the same information. The RFI on the right is an example of how a construction company customized it to fit their needs. So as you might see, while they're really common, the layout can vary, which potentially increases mental load for the viewer. In addition to RFIs, our literature review included types of construction errors, current solutions being used in the construction industry, future solutions in the works, and different project management softwares. So as we delved into research around RFIs in the industry, we found that the average project has about 10 RFIs per $1 million of construction, which is a really significant amount. Additionally, it's really common practice that there's an agreed upon response time for RFIs that's actually decided upon in the initial stakeholder contracts before any work at all is started. So even though there's an agreed upon time frame, the average response time across the industry is about 10 days, and the average price to process one RFI is just over $1,000. So as you might guess, this can add up really quickly.
Looking at the process of how an RFI moves between workers on a job site, it begins when the subcontractor raises a question. The question is asked to the general contractor because the subcontractor does not have enough information to complete the work they're supposed to. If the general contractor knows the answer to the subcontractor's question, then they answer or reject the need for an RFI. If they do not know the answer, however, then they forward this in a formal RFI form like the one displayed previously to the project manager or architect. If the architect or project manager knows the answer, then they can then fill out the RFI and submit it back to the general contractor. But if they do not know the answer, then it is sent to the consultants, such as structural or mechanical engineers, to then get further clarification on the issue. Once this is completed, it is sent back, attached to the form and sent back to the general contractor, who then works with the subcontractor to continue working. This can lead to loss of information because of how long and how many people are involved in the process. There's also unclear expectations set because the subcontractor who raised the question does not get to personally ask the architect or the consultants, so it can lead to some confusion. Companies are also issuing them in the unique formats that Layla talked about, which can also lead to things getting lost. The objectives of the project were analyzed using the same KPIs discussed in our current state slide. An ambitious but doable goal is to decrease the average to 6 RFIs per $1 million of construction, decrease response time from 10 to 4 days, and decrease processing costs to $600. While these goals were set with the help of our sponsors, we did not have a construction site to deploy our solution on, so confirming if we hit these goals was not possible. However, through speculation, we think our solution would succeed at decreasing the frequency and response time of the goals set, and so we moved forward with that.
So after determining these objectives, we came up with 3 potential solutions, and these were a documentation process redesign solution, a central job site workstation, and an augmented reality solution. However, in the interest of time, we will show and talk about our scoring processes, but we'll only be focusing on the AR solution, which we ultimately decided to move forward with. And we can answer any questions regarding the other 2 at the very end. In order to choose the solution to move forward with, we completed both an IRR analysis and an AHP using the following criteria. These were collaborative, scalability, mobile friendly, integration, and usability. The results of both the IRR analysis and the AHP have been condensed into the chart, which is shown here. And in both cases, you can see by the 2 axes that the AR solution performed better than our other 2 potential solutions, which provided a really clear path forward with AR. We can also do a more technical breakdown of our criteria and the mathematical processes after the presentation if there are further questions. So this AR solution that we decided to move forward with involves using AR as a visual tool, which you can kind of see here. These images show how a user might interact with the headset. We chose to specifically use and analyze AR using the HoloLens 2 headset because it's the most commonly used AR device by professional companies. And we also had access to one, which was an added bonus so that we could see how it works. So using AR as a visual tool pre-construction would actually enable site plans to be viewed in 3D, and this could eliminate any potential interpretation issues or errors made by the user. By doing this pre-construction, the user could identify any predicted building difficulties or questions and actually address them before starting work in order to avoid the delay that often occurs in communication channels further down the line, saving valuable time. It could also potentially be used in later construction stages to be overlaid on the worksite to analyze both progress and identify any errors made or expected to be made in the future.
So once we decided to use AR, we had to select the software to use with the headset. We looked at the 3 most used softwares among industry professionals, and the first was Dynamics 365 Remote Assist, which is a Microsoft software. It was the lowest cost at $600 per year per user and the easiest to use. However, it was the easiest to use because there were no construction specific features or visualization tools. It is essentially a AR version of Zoom. So for that reason, we decided to look into Visual Live, which had the best 3D visualization tools of Revit models. However, it also had the highest cost at $40,788 per year per user, which is more than $4,000 more than the other options. Furthermore, the software was somewhat unintuitive and we had poor customer support when trying to get questions resolved. So for that reason, we looked at Trimble Connect, which had almost as good of 3D visualization tools as Visual Live, terrific software user interface, completely cloud-based and accessible features from any device, and enhanced collaboration features. Furthermore, while it was the second most expensive option, it was not that much more expensive than Remote Assist, so we thought that we would move forward with Trimble. To verify and validate that we chose the correct solution, we used the Revit model from the 300 Grant Street project and created a video using the highlighting and functions of the HoloLens and Trimble Connect. We then sent out the video along with a survey to see what MBH thought about the solution. A few highlights from the video are shown here. As you can see, the model is displayed in real life in front of the user. It is simplified to only show the essential components due to the complexity of the design. However, by sectioning the view and decreasing the model as seen here, we can increase the model to display full detail. Now you'll see that we will press the Enhance button and the model will begin to show a lot more of the interior features. Next, we enter Street View to place the model into the surrounding area. The model is full size, and when on a job site, it can be anchored to a specific point so that it accurately aligns with the job site. Not shown are several tools such as measuring, to-do lists, notes that can be placed on specific areas, and several other helpful tools that MBH felt was very useful. While our survey asked many questions, shown are 4 questions that we got 100% confirmation on that our solution met the goals and hopes of MBH. This included confirming that they thought AR was the best of our 3 solutions, that the software accurately displayed the model, that pre-visualization would lead to several benefits, and that the tools in Trimble were helpful for collaboration.
After receiving validation from our sponsors, we determined that Trimble Connect could be implemented in approximately 4 weeks, as you can see here. In order to come up with this Gantt chart, we made the assumption that an employee would not be engaging with the software full-time, and that usage may vary day to day based on available time around a normal work schedule. We also calculated that the total price per employee each year to be trained and use the software would be about $9,000 and $9,700. So in order to fully implement Trimble, we would be providing user guides, which, while we have not yet completed these, will include 2 different parts. The first would contain the business flow explanation, which would be to help the user understand how the software will fit in with current business operations, and would contain use case assumptions and requirements to show when the software is needed and in what ways, as well as milestones and a checklist. The second part would include software training through the Trimble Connect publicly available YouTube videos, which show how to use specific software features and also can be referenced at any time if the user needs to brush up on skills. So following full implementation of AR, we expect the process flow to simplify from this to this, thus reducing the overall time to complete an RFI. So the main changes include the pre-visualization walkthrough with the subcontractors, during which time they can ask any questions regarding the plans. If there are none, then work will begin as planned. However, if questions do arise, the question is addressed immediately, and it will be determined if a formal RFI is needed. If not, then the question is answered, and again, the subcontractor begins the planned work. However, if a formal RFI is needed, and this might be the case with more technical situations or when information just isn't readily available, then the RFI will be filed in the system and work would pause until it was answered. So as you might see, eliminating the need for formal RFIs in certain situations through this process simplifies the RFI process itself, which saves time. So through this new process flow, we determined that there was little to no impact on public health, safety, and welfare, as well as globally and culturally. However, we did determine that there would be a social impact by improving relationships between the project stakeholders, since these relationships can sometimes become strained just due to the stressful nature of the current state of RFIs, which would be improved by our solution. And it also engages the subcontractors to a greater extent, which is really important since they are really the ones completing most of the physical work. On the environmental side, it would lead to a reduction of rework and thus less material waste. And economically, the new process flow would improve company revenue by decreasing costs due to the more efficient work process. So in the specific case of the Grant Street project provided by MBH, the use of Trimble could have saved $237,600, which was calculated from an expected decrease in formal RFIs from 10 to 6, and a decrease in the cost associated with the RFI from $1,000 per RFI to $600 per RFI. Additionally, it also has the potential to increase employee earnings, since they would possibly be considered a valuable asset to the company by obtaining these AR specific skills and training, which not everyone in the job market would have.
In conclusion, the RFI process contains several inefficiencies that we discovered during our project, which lead to increased cost, time, and resources. AR offers the most efficient process flow by enabling pre-visualization, and we found it to be the best solution for streamlining the communication channels, thus reducing time, frequency, and costs associated with RFIs. Furthermore, this report by ARK Invest, a venture capital fund, estimates that by 2030, the industry will grow from $1 to $130 billion. Major players such as Apple and Facebook are getting into the space, and we believe it is going to become extremely mainstream in the near future. For this reason, we recommend for MBH to consider implementing AR into their business, and they hope to begin implementing it in the next 1 to 3 years. Thank you.